Hi, everybody. Thank you for tuning in. In this session, we'll be looking into decoupling with SNS and SQS. We'll be also looking into different patterns with respect to how SNS and SQS could be part of your architecture. So, before we get started, a little bit about me. I'm Zachariah Noel, also known as Zach Jones Noel over the internet. I'm a cloud architect for serverless at Mobility Solutions and Services Private Limited, Bengaluru. I'm an AWS community builder and I love to talk about serverless. So feel free to reach out on LinkedIn or Twitter if you have any queries or anything about serverless. In this session, we'll be looking into what is decoupling. We'll be having a quick introduction to SNS and SQS. We'll also be learning about what are the different type of SNS subscribers and the SNS triggers, SQS triggers that's available, and different architecture patterns with how SNS could be part of your architecture. So, firstly, what is decoupling? In terms of whenever we are building microservice-based architectures or a serverless-based architecture, it's common that we use a lot of components or lot of AWS services, which which will make the architecture overloaded with a lot of dependency between different services. So say if you have you're reading something from DynamoDB, your Lambda function is dependent on DynamoDB's query or scan response, until which it cannot proceed ahead. So similarly, when you have more complex solutions or complex business logic, which has its own working and its own microservice based functionalities, the dependency between these two components would bring in a hard stop for your flow, because there's a lot of coupling or a lot of dependency between the two components. Hence, what we could do is we could introduce decoupling and we'll be ensuring that the dependency is to the minimal. Whenever we are thinking about any microservice based architecture, we think about services such as SNS or SQS or Event Bridge, where we we use them for decoupling and use them as a medium to communicate between different microservices. Again, being said, decoupling is not the same as loosely coupling, but decoupling itself means you're ensuring that the dependency is to the minimal, not reduced to a bit. So whenever you have any function that has to be working independently without the dependency being there on an external or other microservices, that's when you say your architecture is well decoupled. So let us look into SNS and let's have a quick introduction about what SNS is and uh, how it functions. So SNS is a simple notification service which is based on the publisher subscriber model, and this is a fully managed service what AWS provides, where you will have the concept of topics and subscribers. So they could be one topic with n number of subscribers, and whenever there's a message is being sent to a specific topic, all the subscribers would be receiving those that specific message. So that being said, whenever the message is being sent, it's through the external services, where external or programmatic services, which you could be publishing them with APIs or SDKs, or it could even be natively integrated with AWS services, where something goes wrong, you can invoke a specific topic on SNS so that every subscriber to that topic receives the message. And about SQS, SQS is a simple queuing service, which is a fully managed service also from AWS. Whenever we are thinking about decoupled or we are thinking about decoupling our architecture, SQS plays an important role, certain where all of the serverless architectures and microservice architectures adapt to SQS, where there's a queuing system. Whenever any microservice wants to post message, they'll post it to the queue, and the queue is being resolved with another Lambda function, which can be which can receive the message and resolve accordingly. This is mainly used for decoupling, and also ensuring that there is less threshold or less throttling that's happening uh, for the microservice itself. This also can be posted to the queue with externally, meaning programmatically with APIs and SDKs. This can also again be integrated with AWS services natively. So whenever there's something that's not been working fine, so say for example your Lambda function is there and it has a event that is not being processed, so it can go back into an SQS and gets resolved again. So about SNS subscribers, SNS supports different type of subscribers with uh, email-based subscribers or HTTP endpoints. It could be Lambda functions, or it could even be SNS. It could be a SMS-based subscriber. Wherever you're sending a message to the topic, they'll receive it as a text message. And also it could be SQS, also a fire hose and different type of push notifications also. In terms of SNS, SNS natively supports attribute-based filtering. So, say if you have a specific subscriber and you want to you want to filter your messages to a specific kind of use case. Say, for example, you have a topic which has subscribers with email-based and SMS-based, and your topic or your message that's being sent to the topic does not have a mobile number. You cannot send it to the specific uh, subscriber, or you don't have specific values which should not be sent to a mobile user. You could filter it out and ensure that it is being sent only to the email based users. And again, it can even invoke an SQS. So there is a possibility where you can send a message from SNS to SQS, which gets resolved over through Lambda. SQS similar to SNS subscribers, SQS has the concept of triggers where you can add AWS Lambda functions as triggers, and whenever there is a message that's been posted to the SQS queue, Lambda function polls for the event, and as soon as the polling identifies that there is a new message, it invokes the Lambda function. And recently, AWS Lambda functions announced event-based filtering. So similar to what I was mentioning in terms of attribute-based filtering on SNS, SQS also has conditional patterns or event-based patterns which can help you filter out on the events and invoke only for the ones that you actually want to listen to. And based on these conditions which match the event pattern, your Lambda function gets invoked. So the different patterns that we are speaking of is uh, whenever you want to introduce SNS or SQS to ensure that there is decoupling in your architecture. The different patterns are it could be SNS to SQS, like I was mentioning. There is a subscriber for SQS queue. There is a subscriber for SNS as a SQS queue itself, or it could be from SNS to Lambda functions, SQS to Lambda, Lambda to SNS, and Lambda to SQS. So let's look into the first architecture, SNS to SQS. So whenever SNS topic is specified with a subscriber as a SQS queue, the message whenever posted to the topic, it gets resolved and it gets posted to the specific queue itself. So let's look into the demo and set up a subscriber with a SNS topic. So first, let us head out and create a topic. Create the topic. As we create the topic, let us also create a queue. We go with the default options, and we'll say that this specific queue is a subscriber for this specific topic. So we can, whenever you want to create a new subscription, you can head out to the specific SNS topic. So you can go to the topics detailed place, and the subscribers create subscription. And for protocol, we'll go with Amazon SQS. The endpoint would be SNS to SQS, the one that we created just now. And like I was mentioning, you could specify event filters for attribute filtering, but it's optional. We'll go with nothing for the moment. Create subscription. So once we created the subscriber, this is being listed, and it also gives a status as confirmed. And whenever we want to publish, we say test. We go with the world, and there's no attributes at the moment. So when we publish it, and also the you could see from the SQS console that I'm polling for the messages to check if there is any new one that's been received. Okay. The next pattern is SNS to Lambda, where we have a subscriber as Lambda function for the specific topic, and whenever there's a new message in the SNS topic, it triggers the Lambda function. Heading back to the console, we create a new topic which says SNS to Lambda, and we create it. For creating it, we'll also need a Lambda function, which is added as a subscriber. So we'll create a new subscriber for Lambda function. Well, we'll select the protocol as Lambda function, and we'll add the AWS Lambda function endpoint. We'll create a subscription, and when we are publishing a new message, so and publish, it invokes the specific Lambda function. So you could see that it got invoked, and when it did get invoked, so test and publish. After publishing in the CloudWatch logs, we could see that the Lambda function is being invoked, and the complete JSON with the message, subject, and the message is available. The next pattern is SQSQ, with the trigger being Lambda function. So whenever there is a message that's being sent to the SQSQ, a Lambda function which is being added as a trigger keeps polling to check if there is a new message that is available. And once the message is available, it picks it up and invokes the Lambda function. So let us head on to the console. We have a Lambda function that has been created um, to acknowledge the specific. We have a specific Lambda function to acknowledge the messages, or as being which could be added as triggers to your SQS queue. So we'll create a new queue, standard, and SQS to Lambda with the default settings. So whenever we are configuring a trigger for SQSQ, we'll have to head out to Lambda triggers and configure Lambda function, and the, we'll have to enter the name of the function. So here you could see that it's telling it does not have a IAM permission to receive messages on SQS. That's because Lambda function internally polls to check if there is permission or not, to check if the new message is available or not. So we'll head out to the Lambda fund IAM console. We'll attach policies. We'll go with managed policies of SQS, read only, and full access. So attach policy, and we'll save this again. So now that the Lambda function is being added as a trigger, we could send a message. So we say hello and send message. The message is being ready to receive. You could see now that there is a new event where SQS is sending the body of hello to your Lambda function. The next pattern is the the ways of using AWS SDK to send to publish a message to the specific SNS topic from your Lambda function. So we'll have to write the code using we'll have to use AWS SDK, and we'll have to publish the message to the specific topic on. So I already have a Lambda function that's been created where you could see here it's sending the message hello world and a topic on is required. So let us use one of the existing. So this has been sent, this has successfully sent the message to the SNS topic. And from our previous pattern, once the SNS topic receives, the Lambda function should get invoked as a resolver, as a subscriber. So we see the new message that's available with the message hello world that's being sent programmatically from a specific Lambda function. So the other pattern that is there is Lambda functions to SQS, where programmatically we could use AWS SDK with SQS SQS send message to a specific queue URL, and whatever the message is there, it is being sent to the SQS queue. Let us look into a demo of it. So here we have a Lambda function, which is using AWS SDK and the send message API from SQS, where we'll have to enter in the queue URL. So we'll reuse the same queue that we created a while back. So here we'll be sending the message body and we'll be specifying the specific queue. So once we test, the message is being sent, and since the same queue has a Lambda resolver, the trigger should have sent the message to Lambda function as well. So you can see here that from the SQS queue we are receiving hello world. Similarly here, the function is successfully sent the message. So here we have the message that's been received as Lambda, another Lambda function is a trigger to the SQS queue. So with these specific architecture patterns, what we could do is we could introduce a lot of so with this architecture patterns, we could involve in our architecture where we could decouple and we could leverage SNS and SQS to send message and also receive the message programmatically, and also with AWS natively supported triggers. So coming to when to use SNS or when to use SQS, as SNS supports subscribers, which could be email based, SMS, or mobile push notification based, or HTTP or Lambda functions. If your use case is more of sending a notification to any of these subscribers, it's a good choice to go with SNS. Whereas if it's only a lambda function that has to be resolved, you could even think about going with SQS queues. If you're looking for immediate message delivery, SNS is probably the way to go, where you could send the message to a topic and it immediately sends the message to all the subscribers that's available. And again, if your use case is more of a one to many, one-to-many pattern. SNS would be a way where you're sending a message only to one topic, and all the subscribers to the topic receive the message. But if your use case is more in terms to reduce throttling or batch process, SQS would be a better choice, where you could send all the messages to the queue, and from the queue, your Lambda function could be resolved. You could even use a lot of parameter and different uh, configuration changes, which can help you in ensuring that there is a so you could use different parameters such as visibility and message deliverable timeouts, which can help you in reducing throttling for your processing. And if you're also looking for handling undelivered messages, the dead letter queue that is supported by SQS is also a good choice. So that is about the decoupling session with SNS and SQS. Thank you for watching.